go ahead and flip to the very beginning where it says Pythagorean Theorem. Alright, explain the side lengths of triangles. Alright, so side lengths of triangles is what we're going to be exploring today. Pythagorean Theorem. So theorem, does anyone remember what theorem stands for? It's a rule. Alright, another name for it you might see next year is postulate, but they're pretty much the same type of thing. So Pythagoras, he created this theorem, so he got to name it. Alright, obviously you're going to name it after yourself, right? So Pythagorean Theorem, it's the name of it. It explores the side lengths of triangles. So we're going to be focusing on triangles today. Alright, so we're going to first look at how to classify triangles, because that's really important. You have to know, whenever you look at it, what type of triangle it is. So there's two ways to classify it, based on its sides and based on its angles. Alright, so some of this you might remember from your iReady test in 7th grade, alright, whenever they tested you on geometry. So if all the sides are different, let's make sure we're raising our hands. Alright, so if all the sides are different, does anyone remember what that's called? Alright, Ashton? Scaling. Alright, so go ahead and write scaling. So how I remember scaling is that I kind of think of the rainbow fish from back in kindergarten. Alright, whenever your kindergarten teacher read you the rainbow fish, do you guys remember that story?
Yeah.
Right? Okay, so all the scales were kind of different, so that's how I always think of it. I always think of weird things to remember stuff by though. So find something that works for you. Sometimes I tell people my stories and I'm like, that's not going to work for me. But whatever works for you. Alright, so length of two sides are equal. Does anyone remember what that is? Horace?
Isosceles.
Yeah. And it's isosceles. That's one thing in geometry next year when you guys do geometry is it's some of the words that you're going to have to pronounce are kind of crazy, like Pythagorean. I mean, that's Pythagoras is kind of a crazy name. Alright, so length of all sides are equal. The key word here is equal. So Sarah, what would that be? Equilateral. Alright, so this is stuff that we've kind of reviewed and have seen before, so that's why we're able to kind of remember it quickly. Alright, so this is actually something that you should know from 7th grade as well. So triangles based on their angles. So this was talking about their side lengths. Do you see these tick marks?
Yeah.
Alright, what do you notice about these three tick marks, by the way? They're all different. So that's something that you have to know for geometry next year. These do have meaning. What do you notice about these two? They're the same. They both have how many tick marks?
2.
So that means they're equal. Alright, what do you notice about these?
All
They all three have 2 tick marks. So that means they're all 3 equal. So the symbols on these shapes do mean a lot. Alright, so then this one, it says each angle is less than 90 degrees. What kind of angle is less than 90 degrees? Alright, Colton? A cube. Alright, what's a good way to remember a cube? He's so cute. Right? He's so cute. So he's less than 90 degrees. Alright? So if one angle is 90 degrees, Emily? Alright, it's a right angle. So he's called a right triangle. Right triangles are very special. They have their whole own chapter in geometry. That's how special they are. They have a lot of components about them. Alright? So if it's greater than 90 degrees, Kayla, obtuse. Alright, I feel very obtuse lately. So that's how I always remember obtuse. It's very big. Alright. Okay, so any questions on our basing on the triangle sides and triangle angles? Alright. Alright, so what we're focusing on today are solely right triangles. Alright, the Pythagorean theorem only works for right triangles. So, one thing whenever we're looking at triangles, you have to see how they're composed or how they're made up of. Alright, some of these terminologies you may have heard of before, you may have not. Depends on your background in geometry. Alright, so this is something that's really important about triangles. Really, all a triangle is it's composed of a bunch of different angles put together. So does everyone see this angle right here? Alright, you would name him A, B, C. You just name him by his vertices. Alright, and then we're also, can anyone find another angle? What would another angle be? Alright, Nick. Alright, B, A, C. C. Do you guys see the other angle? All right, there's one last one. Emily? A, C, B. So you see how those three angles, when they came together, what did they form? A triangle. All right, so B, he's going to be our right triangle. So go ahead and put our little box to signify that it is a right triangle. So this side length and this side length, they have special names. All right, does anyone know? I just want to check and see if anybody knows what their names are. All right, they're actually called legs. They're the legs of the triangle. So where this right angle meets, it's really important that your eyes go towards that right angle. Because wherever that right angle meets, that's where your two legs form. All right? The one across, or they also call it adjacent, so it's right across. All right, the one across from here, this line segment, he's called the hypotenuse. What do you think? So I kind of related the legs to how they meet and form that right triangle, right? And how the hypotenuse is across from the right triangle or adjacent to it. All right, so what is another way that you might be able to remember the hypotenuse different from the legs? And it can be your own kind of thought. All right, Colton.
The hippopotamus has small legs.
All right, he said the hippopotamus has small legs. All right, that does kind of look like hippopotamus, doesn't it? And hippo, what's normal about hippo? It's pretty big, right? Hippos are big, and they're actually kind of mean. I've heard they're really mean. Like on African safaris, yeah, they're like one of the most dangerous things. Not that I've been on an African safari, but you know. All right, so but a hypotenuse is always which side of the triangle do you think? The largest, and then the legs are the other two sides. Does that make sense? All right, so now looking at this one, it tells us this is 90 degrees. All right, so Christian, which one would be our hypotenuse? C. All right, very good. So we're going to title it hypotenuse. So therefore, Cartel, A and B are both our what? Our legs. All right, now this might sound simple, but the reason why I'm focusing on this is because this is how we use the Pythagorean theorem. All right, you have to be able to identify what side's your legs and what side's your hypotenuse in order to be able to use Pythagorean theorem. Otherwise, you won't plug in the numbers right. All right, so any questions about legs and hypotenuses? What's funny is some of the questions they'll say, find the leg, and you're like, I'm missing the leg. I know that's the kind of stuff I think of at least. All right, so Pythagorean theorem. The most important thing you have to know is what is the purpose of this? Why do we use the Pythagorean theorem? All right, so the purpose of this theorem is to find missing side lengths of a triangle. So you have to find the missing side lengths of the triangle. You're welcome. All right, so once you have that written down, go ahead and put your pens down and focus on this for a second. So we kind of talked about how a triangle is composed of three different angles put together, right? Another way that some mathematicians explain the Pythagorean theorem is through the use of squares. All right, so if you're in my small group today, that's what we're going to be looking at is the use of these squares. All right, so the side length of this square, do you see how that makes the side length of that triangle, A, right? And then this side length of this square makes the side length of that triangle, and so on. All right, Sarah, which one would be our hypotenuse? C. All right, and then A and B would be our legs. All right, watch as they kind of unfold them. So they basically took these and they unfolded them. This is the Pythagorean theorem. If you take the area of this square and add it to the area of this square, all right, then that equals the area of this square, which is actually pretty cool. All right, so how do I get area from a squared? How did I know they were talking about area? Think back to your geometric spheres that you guys just made. All right, it's a square. How do you find the area of a square? Freddie's waving at me. All right, so Freddie, yes. Length times width. All right, so this, or it's base times height, same thing, right? So since this is standing up, then that would be base times height. All right, so if my height is A and it's a square, what is the base? It's a square. So what is it? It's the same, so it's also A. So if we do base times height, what did you guys learn in algebra? A times A is what? So do you see how that's the area? It's representing its area. All right, same thing with this. If this is B B times B squared. So they're representing their areas. All right, so that's just kind of the reason why the Pythagorean theorem works. So this is the Pythagorean theorem. All right, so A squared plus B squared equals C squared. Some of you may have seen that on like nerdy math t-shirts before. You know, some people have those like pie eating the, yeah, Miss Dobson wears them all the time. All right, so A squared, what's another name for A that we just learned? What is he called? He's called what part? He's a leg, good. So really, this is leg 1 squared, right? Plus leg 2 squared equals the hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. It doesn't really matter which one's your A or which one is your B, because regardless, you're adding them. So the order in which you add things doesn't matter. What property is that? The order in which you add things doesn't matter. It can switch. Well, addition property of equality, it has to involve where you do what you do to one side, you do to the other. Braden? So subtraction property of equality. So properties of equality are back to this. So this is the property of equality. What would I do to get x by itself?
Subtract 2 from both sides.
Subtract 2 from both sides. So what property of equality is that?
Subtraction.
All right, or it could be addition because you could add a negative, right? So this would not, if you take A squared plus B squared or B squared plus A squared, they're going to equal the same thing, but because of what property? You could switch the order in adding. What is that called? All right, Nick? Commutative property. You commute, right? They commuted. They switched places. So they're commuting. I always think about commuting from home to work, all right? Or you guys commuting from home to school. All right, so this would be the commutative property. So it doesn't matter which leg you put in for A or which leg you put in for B. You can pretty much choose. But the hypotenuse always has to go in for who? The C. All right, so let's do some math. There's a lot of vocab. All right, but vocabulary, you're going to find out in geometry, there's a lot of vocabulary. All right, so go ahead and get used to it. All right, so it says use the Pythagorean theorem to find the unknown side of the, underline this, right triangle. Pythagorean theorem only works for what kind of triangles? Right triangles. So if you try to use it for some other, for a scalene triangle or a acute triangle or an obtuse triangle, it won't work. All right, and this is a right triangle because you see the little right angle. All right, so the first thing you have to do is write down the formula. So A squared plus B squared equals C squared. All right, Kayla, A and B are referring to what parts of our triangle? The legs, good. All right, so A and B, what would be one of my legs, Nick? All right, 8, so we put in 8 squared. Would it matter if I put 8 in for A or B? It doesn't matter. All right, Colton, what's my other leg? So it would be 15 squared equals Christian. X squared, good. Because what is it that we're trying to find? The C, the hypotenuse, good. All right, So from this part, we just use PEMDAS. All right, so then 8 squared, Quave, what's 8 squared? 64. All right, Horace, do you know what 15 squared is? All right, well, think about it. Well, what is 12 times 12? 144. So it's going to be bigger than that. All right, it's got to be a perfect square because we're squaring it. All right, so let's see. Jaden, do you know what 15 squared is? This is kind of a tough one. I only know because I'm a math teacher, I think. Because I memorize it. No, it's too big. All right, yeah. It's 225. Horace, I totally put you on the spot. I'm sorry. All right, so then, why did I do 8 squared and then 15 squared? What is it that I'm using? Exponents first. All right, so 64 plus 225. Now we can add those. All right, so we got 9, and then that would be 6, and then 8. So 225. Whoa. I'm paying attention to Donovan. He doesn't get that there's a sign on the door. There's a sign on the door. So 289 equals x squared. Took him a minute. He figured it out. I love Donovan. All right, so even though he takes his shoes off in my class every day, and Ron's like, Donovan, put your shoes back on. He's always walking around barefoot. All right, so this is reflecting back to your Algebra 1, what we kind of just learned. All right, so we have x squared, but we just want x. So how do you unsquare something? All right, how do you unsquare something? Well, that he said divided by x, and it's sort of similar. So what you said technically isn't wrong, but yes, you square root it. All right, so good job, Jaden. All right, so 289, the square root of 289. I feel like that is that 17? 17 times 17. So 7 times 1 is 7, plus 4 is 11. Yeah. All right, so x equals 17. All right, so this is crucial. Let's say you solve this whole thing and you get the answer. How do I know this is a logical answer for my hypotenuse? Why is it logical? Kayla? It's bigger than the legs. Does that make sense? Because doesn't the hypotenuse have to be bigger? So if for some reason you got a number that was smaller than 15 or smaller than 8, then you did something wrong. All right, and isn't it relatively close to 8 and 15? It's reasonable. You didn't get like, 300 and something. Then you would be like, wait a second, something wrong happened. All right. Okay, so this one we were finding the hypotenuse. So we plugged in the legs and we solved for C. All right, and when we solved, we were using what method? When we solved, what were we doing? PEMDAS? PEMDAS? Yes, PEMDAS. All right, good. All right, so this is our next example that you're going to see. All right, so this is some math humor. I don't know why I find it so funny, but every time I see where it says missing leg, find the missing leg of a triangle, it just kind of, I don't know, it's just silly. Why do they call it a leg? It's just interesting. And where do they get hypotenuse from? I'm sure there's some book on it. Cartel's going to read it when he gets home, right? How is it called a hypotenuse? All right, so find the length of the third side of the right triangle. Underline that, right triangle. It only works for a right triangle. All right, so give an exact answer in an approximate to 3 decimal places if needed. All right, so how is this one a little bit different than the one that we did before? What is it? Look at the numbers and how they're placed. Ashton.
Well, I believe it's the leg.
Yeah, we're missing the leg. They gave us the longest side. All right. So one thing, if this was multiple choice, you would pick something that was smaller than 68, right? Because that has to be the longest side. Alright, Sarah, I'm gonna ask you to do me a favor. Will you bring me a calculator, because I don't know what 60 squared is. Alright, do you know, Christian? I feel like it's 3,600 or something. Because 6 times 6 is 36, and then you'd add the zeros. Alright, so, thanks, Sarah. 3,600? Alright, so I can do math in my head, I was just making sure. Sometimes it makes me nervous doing math in my head. Mr. Johnson can do math in his head, like percentages and stuff, and I'm like, I'm a math teacher, I'm over here like writing it down. But, you know, everybody has their own strengths. Mine's math, but I have to like write it down. I'm not one to do it in my head. Alright, so first thing we need to do, write down the formula. Alright, so a squared plus b squared equals c squared. So if you can't do math in your head, don't feel like you're not good at math. It has nothing to do with it. It's all about knowing the steps. Alright?
Can't figure out 2 plus 2.
Yeah, 2 plus 2, we should know that. Aiden counted to 7 yesterday. I was really excited. Yeah. Alright, so this one, he's what? Yeah, I'm at Alright, Horace, 60. Where should 60 go? In A, because he is a what? What's his name?
The leg.
He's a leg, good. So 60 squared plus b squared equals, what would go in for our c? Well, think about it. We have 68. Why is it 68? And that is called the what? The hypotenuse. It always goes in for c. Alright? Now, sometimes when they present these triangles to you, they might be flipped. So these kind of are sitting pretty for you. They're sitting with the 2 legs and the hypotenuse right over here. But they might have it to where it's like this. Alright? Or they might even have it like on its side, like this. So you have to know that the hypotenuse is always going to be across from the 90-degree angle. Alright?
Write those down.
No. I'm just showing you how they can present it to make it a little bit more difficult. Alright, so to solve it, what should be my first step? Alejandro, what do you think we should do? Alright, well we can't do that first. You're ahead of me. Alright, before I can do that, what should I do, Quave? Yeah, you have to square all the numbers. Does that make sense?
Yes.
Alright, and then Alejandro, we're going to do what you suggested. So 60 squared, alright, I was right before, is 3,600. Alright, and then plus b squared, which we still don't know. And then I have to figure out what 68 squared is, which is 4,624. No, don't worry, I didn't do it in my head. Alright, what's up?
So, oh, never mind. I thought about it for a
Are
second.
you sure?
Yeah, because I was going to ask why is it 3,600 squared, but then I thought, well, this means.
We already, good, we already squared it. But that's a good question, we are clarifying, make sure you got it. Alright, so Alejandro said we should subtract, and half the time Alejandro is always a step ahead of us because his mind works fast. Alright, so why do you think he wants us to subtract? Alright, Nick. Alright, isolating B, good work, use of your terminology there. So we're going to isolate it. Okay, so remember that property you guys kept wanting to use earlier? The property of what? Equality, right? Property of equality. We're using that right now, aren't we? Alright, what we're doing to one side of the equation, we're having to do to the other. So this would cancel out. So 4,624 minus 3,600 is 1,024. Alright, the Christian, what do we do on both sides? We square root. Alright, so when I square root both sides, I get b equals 32. Alright, hey, I want to show you guys something really quick. Remember how earlier when I asked Jaden, he said, whenever I said, what do you do to unsquare something? And he said, oh, don't you divide by b? If I take b squared and divide it by b, alright, what do you do with your exponents when you divide? You subtract them. Alright, so Brayden, are you okay over there? Are you doing a gum deal? Or no? Alright, he's always passing out gum to everybody. Miss Knighton asked me where to get a piece of gum, and I told her to go to Brady. Alright, so 2 minus what? What's it, this one's exponent? 1, right? So 2 minus 1 would be 1. So wouldn't that give us just b?
Yep.
So was he wrong in saying that you could do that?
No.
But why would that be really difficult to divide? You have to do it to the other side. Do you know what 1024 divided by b is? No. Was that the...
Miss Johnson,
Yes. Hello?
you have Nicholas Mims.
I do.
He's needed in Mr. Edwards' office, please.
Okay. It's okay. We can do it.
Do it what? Do it this time.
Bye, Nick. Alright, so that's why you would run into a problem. So that's why we square rooted instead. But that was a good idea, because you're using your exponent rules. Alright, so we found the missing leg this time. Alright, so there's one last thing that I'm going to show you guys before we go to our stations. Alright, so Pythagorean triple. What's a triple? 3, right? So 3 numbers. Haven't we been using triples? A, B, and C, the 2 legs and the hypotenuse, so we've been doing it. Alright, so all they want to do is to test the Pythagorean triples. So you basically plug it into the Pythagorean theorem, see if it works or not. Alright, so that's what we're going to do. Alright, we're going to use the triangles provided, identify their sides as leg 1, leg 2, and the hypotenuse, plug it in, see if it works. Alright, so a squared plus b squared equals c squared. Emily, what are our legs? Alright, so it'd be 3 squared plus 4 squared equals, and then our hypotenuse, alright, would be what, Patel? 5 squared, good. Then Brayden, what should we do first? Yeah, we should do exponents for every single one. So 3 squared would be 9, 4 squared 16, and 5 squared is 25. Alright, how can I simplify this a little bit further? Yeah. Combine like terms. Y'all's terminology is like really making me excited. You're using all the correct algebra terms. Your geometry teacher is going to be like, oh, that is impressive. You didn't say you add the numbers. Alright, so 9 plus 16, what is that? It's 25. So that worked, didn't it? Alright, so we put a little check. Alright, now let's test this guy. So a squared plus b squared equals c squared. Alright, Claudia, what are our legs? Good. Alright, Freddie, she said 6 squared plus 7 squared. Claudia's so quiet. Unless she's yelling at Cartel. Alright, then, alright, and then Horace, what's our hypotenuse? Good. It's going to be 10 squared. So 6 squared, Ashton, is what?
36.
Good. Alright. I always secretly get excited when people don't say like 12. I'm like, good, they understand what exponent means.
I was about to say.
Well, it's your general, like, you know, it's like that's the initial reaction of people is to just to double it, but you're actually squaring it.
Yeah, I just think.
Alright, plus 49 equals what? 100. Alright. Well, 36 plus 49, I can already tell that whenever I add these, I'm going to end up with a 5 here. You see what I mean? Because 6 plus 9 is 15. So that's actually going to be 85. And that's not 100. So the Pythagorean theorem didn't work here. So you cross it out saying, nope, didn't work. So your equal sign has a little slash through it. So what do you think?
Doesn't that also say no solution?
Yes. Alright, so yeah, it's basically saying no solution. So what do you believe this proves about the triangle? This one, it worked. What do you think it proves about this triangle? This one, it didn't work. What do you think it proves about this triangle? Alright, Claude. The first one, and I gave you guys a hint, it was a right triangle. Alright? Where this one was not, right? So that means it was either an acute or an obtuse angle, or obtuse triangle. Alright, so what we're going to do actually in the next class is I'm going to show you guys the little rule for this, and then you can identify if it's acute or if it's obtuse. Alright, so this one was definitely right angle, but sometimes, I'll let you know, they're just not even going to give you that. Alright, they're not going to give you the right angle. You just plug it in and see if it works or not. If it works, it automatically is a right triangle.